Skywatch Media News for September the 6th, 2021. A sudden and unexpected surge in solar activity over the past few weeks has raised a lot of eyebrows, especially among researchers and scientists whose job it is to study the sun's behavior and its effect on the Earth's magnetic field. A large explosion on the sun's surface on August the 28th from sunspot region 2860 sent two solar CMEs barreling towards the Earth. Forecasters have predicted that the CMEs would deliver a double blow to the Earth's magnetic field, each of them striking us within a matter of hours. Although they presented no danger to the Earth's infrastructure, they were expected to produce a G1 and a G2 geomagnetic storm. The double whammy, which was forecast by the incoming CMEs, just happened to miss us. But we're not out of the woods by any stretch. A new episode of Unrest has appeared as of September the 5th, as another round of charged particles originating from an equatorial hole in the sun's atmosphere is expected to reach our planet. Geomagnetic storms occur when the sun emits massive bursts of energy in the form of solar flares and coronal mass ejections. The electrical charged particles move towards the Earth at a speed of about 3 million miles per hour. Sunspot AR 2860 is becoming an extremely active region at the sun's surface. The giant sunspot is about to position itself over the sun's western limb, which poses considerable danger for Earth. And here's why. Sunspots such as 2860, located near the sun's western limb, are magnetically connected to our planet. Known as the Parker Spiral Danger Zone, the lines of magnetic force originating from the western limb curve around and touch the Earth at speeds of nearly 900,000 miles per hour. If an eruption of sunspot 2860 were to occur while passing through this danger zone, the magnetic particles would be funneled back to Earth as a radiation storm, peppering satellites with high-energy protons. Solar activity is unpredictable, and each and every solar cycle produces its own unique capabilities. This cycle is behaving in unexpected ways, producing more frequent sunspots and stronger solar flares, which is why scientists are sounding the alarm. July and August of this year was one of the most active for visible aurora displays across the Earth's northern latitudes. Time-lapse footage taken from aboard the International Space Station depicts the green waves of light shimmering over the northern hemisphere during the month of August. Researchers from the University of California, Irvine, have indicated that one of the biggest dangers we face on this planet is coming from space, from a solar storm the likes of which has not been seen in over 100 years. The biggest concern from an incoming solar tsunami would be its effect on global internet security. In a world which relies on uninterrupted internet operations, a significant solar storm has the potential to disrupt critical services and create unimaginable economic losses. In a worst-case scenario, global outages could last for months, and this could lead to an internet apocalypse. Major solar storms have inflicted our planet in the past, but they occurred primarily before the advent of the internet and high-speed communications. The strong CMEs created by so-called solar tsunamis can be hurled towards Earth as waves of hot plasma that rise higher than Earth and expand out in a circular pattern for millions of miles in circumference. According to the scientific study, if one of these powerful waves were to hit the planet, some 20 to 40 million residents of the United States in the dotted areas could be left without power for as long as 2 years. Those living in the brown shaded areas could see a system collapse, whereas other parts of the country are at risk as a result of vulnerable transformers. Of particular interest are the internet cables that run along the seabed, which are at greater risk of failure, not from a solar storm of itself, but rather from the strong electrical currents that would be generated when the storm hits the magnetic field. Although these fiber optic cables rely on light for functionality, the cables that run between continents are connected by repeaters that use electricity. If the solar currents hit the repeaters, it is likely that the amplitude of the electrical charge would be 100 times greater than what they are designed for. In addition to the high conductivity of the seawater, the probability of failure would be increased. Given the unpreparedness of the global internet infrastructure system against powerful magnetic storms, such a scenario is not out of the realm of possibility. Over the past 20-plus years, the sun has been in a period of lower activity, which has coincided with the rapid growth of technology, and therefore we have a limited understanding of whether our current infrastructure can withstand the destructive force of powerful CMEs. It's been estimated that the probability of an extreme space weather event lies somewhere between 1.6 and 12% per decade, which may not seem like very good odds, but it only takes one direct hit from a massive bubble of electrical particles to knock out the power grid, and when that happens, all bets are off as to the odds of a speedy recovery, since any necessary repairs would require an operational internet. So what can be done to prevent the apocalyptic breakdown of the world's technological infrastructure? A primary concern would be the relocation of the infrastructure itself. Many of the cables that stretch across continents are presently located in higher latitudes as a result of the increased melting of Arctic ice. But this poses a problem, since they will become more susceptible to solar storms. Therefore, a more realistic alternative would be to place the cables in either Central or South America. The use of a warning system would also be helpful. It usually takes 4 days for solar wind particles to reach the Earth. This provides ample time to temporarily shut down the infrastructure, which would provide a form of limited protection. The best and most sufficient means of limiting any damage that might occur during the storm is by designing more resilient systems that would allow for a faster recovery. But as we all know, talk is cheap, and actually paying attention to the threat and planning ahead is critical for the long-term resilience of the infrastructure. On September the 5th, an immensely powerful sonic fireball blasted across the English Channel. The event was witnessed from both sides of the channel, and there were multiple reports of sonic booms and other related sounds. The meteoroid entered the atmosphere above the Atlantic Ocean below Brittany, and it traveled to the north-northwest, ending its light path above the channel at an altitude of 24 miles. Its weight at time of entry was estimated by the Interplanetary Observation Network to be about 88 pounds. It entered the atmosphere over the channel at a speed of 48,000 miles per hour, at a 34-degree angle relative to the horizon before completely disintegrating. The event was captured by numerous webcams and video stations in the vicinity. As you look to the sky, there will be days when dark clouds will obscure the sun's light. But there will always be a silver lining that reminds you of brighter days ahead. Stay safe, everyone. Thanks for watching, and always keep looking to the sky.